Have you ever thought of the science behind a necklace or a ring? Probably not, I'm guessing. Today we're actually going to be looking how art and science meet and can actually create something very beautiful. To do that, we're going to have to go find an expert. So let's see if we can find one. Oh, hi! This is Christine Pedersen. She's actually a jewelry artist. So first questions first. What would you say is the reason you got into this?
Well, Brian, I've always been very creative. I loved drawing and clay making as a child, but I went away and studied a science degree, and years later I've come back into art making, really so that I could bring my personal life into what I do. I think it's really, really important, and the science really informs so much. So this is a necklace that I made out of the pull tabs in juice and milk cartons.
It's absolutely beautiful, but I was wondering if I could actually get my hands a little dirty and try something myself.
Well, you can, but first we've got to kit you out. Okay, Brian, so before you can get started, we've got to get you wearing the gear.
I'm excited.
Are you ready for this?
Is this my size?
I don't know, just put it on.
Okay. Yes.
Okay, these are Kevlar.
Yes.
So these go on your arms.
I thought these were socks.
So that's how it goes on?
What are you saying?
Is this how it goes on?
I can't understand a word you're saying.
Is this how it goes on?
Yeah.
Okay.
Okay, the good news is you're going to do some soldering and you don't need to wear any of that except the apron and the glasses.
Cool. Okay.
So what we're going to do, we've got two pieces of copper here, and we're going to join this little arch onto this little sheet of copper, and that's pure copper, but what we've got here is some really low melting point silver alloy. This melts at a much lower temperature than the copper, so we're going to use this to join those two together.
Sounds great.
You think you can do it?
I'm gonna try.
Okay, let's give it a go.
Beautiful.
So now you're just going to work, moving the flame around that metal and warm it up. So now just put some pieces right next to that little arch. Beautiful.
There we go.
Okay, so now what we want to do, I think, is to just really move the torch around, and let's see if we can get it to melt.
So why is the silver alloy melting and the copper's not?
Well, it's this principle of having lower melting points. When we're joining the two metals together, we're exploiting the fact that one metal has a lower melting point than the other one. So we're using that silver solder, melting it, to ask it to actually go underneath and join the two pieces of copper together. You know what? It's all melted.
Okay.
I think we're ready to turn off the torch.
Perfect.
Okay, Brian, so let's have a look at how you did. Well, you did get the solder to flow, look.
Excellent.
And I think we can show that this side isn't attached. Well, what about this side? Wicked.
Not bad.
He did the job.
So Christine, I noticed that was pretty easy, but you mentioned a couple terms that I want to know more about. You mentioned something like pure substance and an alloy. Do you want to explain those a bit more?
Sure, let's go over to the anvil.
Sure.
So what you did was just join two pieces of copper with some very low melting point silver solder. And that's because that metal melted at a much lower temperature than the copper did.
Right.
And you found it pretty easy, yeah?
Of course.
Okay, so this anvil is made out of steel.
Right.
And right now that copper is very soft. Do you want to see if you can actually bend it?
Sure.
Go ahead.
So what do I gotta do? Just put it on the anvil?
Sure.
All right.
And then you might need this.
Yes. All right. Do I just hit it as hard as I can?
I wouldn't go as hard as you can.
All right. Hard enough?
Yeah.
All right. That was pretty easy. Must have dented the anvil though.
You think? Let's just have a look.
Nope.
No.
Nothing.
So, do you think you could bend this little steel bar?
I'm gonna try. What's it made out of?
That's a little piece of steel alloy.
So it's just like the anvil.
It's just like the anvil.
But this is so small.
Try harder, Brian.
All right. The bar wins this time.
So basically what we have is different metals have different properties, and that's what we use in jewelry and in metalwork. The anvil is made out of a steel alloy that's it's iron mixed with silica and a bit of chromium, and what it makes is a really, really hard metal. So we rely on that to work on so that we can work our metals, we can hit them and we can form them, but it doesn't do anything to the steel.
Are all alloys this tough all the time?
It depends. Some of them are much softer, but what we're really doing when we're making an alloy is changing its properties to what we want it to be. What do we actually want the metal to do? So we're always thinking about that, and we have a range of alloys that we work with that have all been really made to have their properties just how we want them.
So I really liked working with the copper and the steel, but when I think of jewelry, I actually think of gold, silver, and rocks. So how do you guys actually work that in?
Well, you're absolutely right, Brian. We always pick the metal to do the job. And so to put the metal around that lovely stone, we used pure silver, which as you can see is really, really bendy. But to make the ring, we wanted a metal that's much, much tougher. So that's when we use an alloy.
Oh, perfect. What about the rock?
Well, there's one more thing I wanted to tell you about, and that's a really, really cool example of a solution, is a colloid. And that's where we have one material that's actually held in suspension inside another. So these are really, really good examples of that. These are opals, and this is silica, just like the stuff you find in sand on the beach. But in this case, it's just been suspended in a little bit of water.
That's fantastic. I like that blue one.
Yeah, it's really pretty.